A PWM signal can control colored RGB LEDs, and the Nexus 4 that we're using contains a couple of them here. As you can see, they're changing their colors. So as an application to test that design that we just went through for the enhanced or the improved pulse width modulation circuit, I will use 3 of that circuit to control the red, the green, and the blue. Each one of these LEDs actually contains 3 different LEDs. It's the red, the green, and the blue LEDs. You combine them with different intensities and they generate these different colors. I'll focus on creating a driver that will allow you to control the color of one of these LEDs, and of course you can replicate that driver to control the other one. So let's go to Vivado and see how we can do that. So I went ahead and I actually wrote that driver because it's really straightforward and simple. What I did is I said, okay, I need to control the red LED, the green LED, and the blue LED. So I need 3 circuit that generate 3 different pulse width modulated signals, and this is here and here and here. Okay, so I just instantiated them, and of course all of them will need some sort of a resolution, so I decided to use the same resolution for all of them. So that resolution, I called it R in here, and I used it in that particular one. And for the timers, internal timers, the ones that we control them internally, I decided they're exactly the same because all of them are LEDs. I'm controlling LEDs. So I decided to give them the same exact timer bits in here and timer bits in here and timer bits. I didn't expose that to the outside world, and you're going to see that why in a second. And for the final value, of course, I can control this particular circuit with one frequency. I can specify this one with another frequency, and I can specify this one with another frequency. So, but what I decided to do is like, well, there's all LEDs, so let's control them with the same frequency. So what I have in here is this particular design in here. So it's one, so basically I decided that 195, which operates at about 2000 kilohertz or 2000 hertz, which is 2 kilohertz. And there's nothing else in here. So the driver itself, if you want to use it, you don't have to remember that it has 3 pulse width modulation circuits. All you have to know is you need to provide it with a clock, you need to provide it with a reset, and you need to give it what is the duty cycle for the red, what is the duty cycle for the green, what is the duty cycle for the blue. And for that reason, we need the R, which is the resolution. That's why I exposed it to the outside world. And the output would be the pulse width modulated signal for the red LED, one for the green LED, and one for the blue LED. So if we are to design or to use this particular circuit, which I'm in a real life application, we're going to have to wrap it with some sort of other circuitry. But before I do that, let me just show you at least a schematic of this particular circuit here. So the schematic of the circuit that you just saw is really straightforward. So a pulse width modulation in here, another one in here, another one in here. And what I'm doing is I'm providing it with the same exact final to all of them, so they all generate PWM signals that have the same exact frequency, and I specified it with a parameter to be 2 kilohertz. And this will have its own duty cycle, this will have its own duty cycle, this would have its own duty cycle, and we're going to expose these to the outside world so that we can change the different colors for the different LEDs. And for an application, I went ahead and I actually created this particular application. So really what I did is I actually instantiated an RGB driver, the one that we just discussed here with the 3 pulse width modulation circuits. And I connected the different signals for the duty. I exposed, basically I said like, okay, I need something for the R duty, the green duty, and the blue duty. And what I'm really after in here is an implementation on the board. And if this is 8-bit, or actually it's 9-bit, and this is 9 bits because R is 8 and this is 0 to 8, that's 9-bit. That means each one of them will need 9 switches if I'm to connect them on the board, and I don't have 9 times 3 is 27. I don't have 27 switches on the Nexus board, so I'm gonna have to hack my way around it a little bit. But anyway, so I'm using that driver, and the hack that I'm doing is actually really straightforward. What I'm doing is I am creating 3 different registers, one for the red, one for the green, and one for the blue. And what I'm doing is in here, you can see that I actually combine, these are the sequential part because there's a clock. Okay, and here's the combination part because there's no clock in here. What I did is I created 3 different registers to store the different duty cycles, one for the red, one for the green, one for the blue. For the reset, I'm gonna zero all them out. And then this change color is actually, I'm going to connect it to the outside world to a push button. So this push button, I push it, whatever you have on the color intensity would be some sort of switches on the board. it will be writing it to one of the R or G or the B color, and you specify that with a color selector, which is 2 bits, and that's what you see in here. So what you see in here is the color selector is actually a 2-bit that tells me if you have these switches set to 0, the switches will be changing the red color. If you have it at 1, the switches will change the green color. If you have it at 2, the switches will change the blue color. Of course, every single time you need to press that change color push button, okay, which I'm going to connect it to I believe the center button or the middle button. And here I'm generating one for the red LED, one for the green LED, one for the blue LED, and I'm going to connect them using the constraint file. And as well, I just want to show you that I'm also going to output the signal so that we can see it on a scope. Here I open the XDC file just to show you what this output in here. So in the XDC file, I uncommented the clock, connected it. I connected the 9 first switches to that color intensity. That will tell me basically I can decide the duty cycle for each one of the colors. And then the last 2 switches to the color selector. That's what I did. And then I went ahead and you'll have RGB LEDs. You have a couple of them. I'm just using one. You can use 2 if you wanted to, but I'm just using one here. I connected the blue, the green, the red. This is how they are written in here. It's a B before the G and the R. And then I went down in here and I said, okay, for the reset, I connected to the CPU reset and the change color, which is the middle button. But this is here what I'm about to show you, which is that output in here. I want to output the red LED will get a signal that is a square wave. I'm also going to output it to the outside world using one of the PMOD headers on the Nexus board. And the way we do it is here. I have a bunch of PMOD headers. I have a JA, JB, and JC. I'm going to use one of the pins just to output the red. You can of course output the green and the blue. And what I'm really doing to output it is just I'm saying, hey, the one on the jumper or basically the PMOD header JA is the same as the red LED. So let me show you where that red or that PMOD header is on the board. So that PMOD headers are here. So these are the PMOD headers in here. You have actually 4 that are digital, and this one here is actually an analog input. It's connected to an ADC, an analog to digital converter. But anyway, for the purpose of this particular part, I care that we can actually connect different peripherals in here. But for now, I'm just outputting a signal. So the exact signals I'm actually using JA. So you can see the name here, JA in here, JB, I believe in here, and then JC, and then here it's a JD. And what I decided to do is I'm just going to output number 1 in here. I'm going to take it to a scope. And then here, actually, you need to connect the ground from the board to the ground in your scope. Really, I don't have a scope. What I have is one of these analog discovery stuff here that will actually show me that signal, and I'll show you that diagram in here, or like the output signal. So I'm going to control the red, and I'm going to see exactly the duty cycle that I'm actually setting up on the switches. So I went ahead and I actually uploaded that bit stream to it, and now it's on the board. So the switches here, the first 9 switches from 0 all the way to 8, control the intensity of one of the colors, either the red, the green, or the blue. And then I can select which one I want using these 2 switches in here. So they're currently at 0, 0. That means it's red. And I went ahead and I connected this here. As you can see, that here is what I can see, and I can see it's now at 0, and then it is at 0. So what I can do is I can technically just like go ahead and just turn it on a little bit in here. So I'm gonna basically put the number 3. The duty cycle will be 3 divided by 256. And once I push that middle button in here, it will actually write it to the register that is storing the red color. So I'm going to do that in here, and you can see the red color is now on. It's very subtle, but it's on, and you can see here on the timing diagram that it is on for a short period of time. I could increase the intensity. For example, I can go all the way to 7 in here, and I can just do that in here, and now I increased it. And of course I can change it, and you can see that the red color is much, much brighter now. I can change it, and I can change it. I can add it in here, or maybe I can actually reduce the duty cycle, as you can see with the switches. All of this is actually for the red color. Okay, so now what if I want to add the blue color? So I'm not outputting the blue colors on the PMOD headers. But I can definitely control them because my circuit allows me the red, the blue, and the green. Let's do the green for now. The green is actually when I actually do 1. So this is at 1. Now whatever intensity I actually put in here will be set for that green. Frankly speaking, I'm going to reset it so everything is at 0, so that you get to see that it's actually setting up the green color. And you can see in here it's actually now the green color. Okay, what I did is that when I did reset, it put 000 in all the colors, and now I just wrote whatever I put in here, which is I just made the switch number 7, which is pretty high. It's like 128 or so, like in here. So the duty cycle is high. Of course, you can't see it on the diagram in here because I'm only outputting whatever I'm outputting to the red. So the last one is here. I can put the 2, and I can definitely write that to the blue. And now, what if I want to mix these colors? For example, I know that blue and red is a pretty purple, and that's what I get in here. I don't know if you can see it on the camera, but it's purple. But anyway, I can definitely reset everything in here, and I can say, well, let me just do that green, like red, and for example, the green in here. So you can do, that's a little bit on the yellowish side. I recommend that you play around with it just so that you get to see it. And of course, again, like if you put that switch in here, 8, let me just do reset, you're going to get the brightest color here because that 8 is actually the 256, and any other numbers in here, you're going to keep getting the same exact color. And let me just show you that on the red, for example. Let's say reset, and then you say, well, I'm going to go to the 8, and I'm going to do red in here. I'm writing it, and you can see on the diagram in here, it actually moved to 1 because it's 100% duty cycle. It's always on.